Hello folks, I am back. Today is a topic that I would categorize broadly as quote unquote inspiration porn. This would fit roughly in with my Why You Should Learn to Program the Hard Way video. I think it's mostly for that kind of audience. What do I mean by inspiration porn? I mean, I'm going to show you that I did something that a lot of people say that you cannot do. And for that reason, I will not be able to explain everything that I did because it actually was a great deal of work for me. But what I will be able to do is give you a rough outline of what I achieved and how I accomplished it, where I was when I started it, and then I can allow you to draw your own conclusions from that. Hopefully, fitting the inspiration porn category, you will then go off and be inspired to do something similar. That's my hope. Okay. So what did I do? I did this. I made this thing. Okay. What is it? Well, it's actually the beginnings of a 3D game prototype. So I've got a grid. What I wanted to make was something that is inspired by one of my favorite games, A Monster's Expedition, which is this 3D Sokoban kind of game where you roll logs around. Love that game. Kind of similar to Steven's Sausage Roll in some sense. So I had an idea for one game that was like that. And I actually still want to prototype this game eventually. But the reason I'm not doing it is because I wanted to try some other genres because I think they might be more profitable. So here we are. This is a three-dimensional starting prototype of a game. It took me about 1.5 to 2 months to get to this state. There are some interesting things about it. One of which is this game was actually, this thing actually runs not on just one platform. So it runs on both Mac OS and Windows. And it uses separate rendering pipelines for both. So on Mac OS, it uses Metal, and on Windows, it uses Direct3D 11. Okay. I would like to point out that it does not do all of the things which are typically expected out of a 3D kind of game, quote unquote, engine setup. Okay. It does not do really fancy light mapping. It doesn't do bone animation for these characters. Right? So I've got this guy that he's a 3D model that I've loaded. He doesn't even have any normal mapping on him, so far as I can tell. So it's very kind of cartoonish style, right? This is not, in any sense, in any appreciable sense, a robust 3D rendering setup at all. And you will see that. What this is, in my opinion, is something that someone who wants to make a 3D game could use to begin to prototype the gameplay in that 3D game. That's what it is. Okay. So what I want to say to begin with is I did this with basically no knowledge of 3D, and it took me about 2 months to get from having my own 2D platform layer to being able to do this. Okay, that's what it is. What no? We have a comment. What? No KD spatial partitioning? Yeah, unfortunately, no. Why did I start doing this? I can't remember exactly what the historical reasons were, but I had a friend, and at the time, I had been making cross-platform two-dimensional games. So I have one of these. You may have heard of it. I will run it right now just so you can see if it runs. Okay, this is one of my 2D games. It's a game called Mooselutions. It is cross-platform. It runs on Windows and Mac OS. It's a complete product. I shipped it. I make money on it. Not a lot, don't worry. I'm not like rich. My friend challenged me because my friend is a professional iOS engineer. We worked together. I, while working in mobile apps, began to get dissatisfied with the state of affairs in mobile apps generally. Primary state of affairs being, why the heck do we have two completely separate code bases just to draw some two-dimensional graphics? Right? If I want to do an iOS app, I've got a completely separate Swift UI thing that I got to do. And if I want to do the same thing in Android, I got to like go and use their kit, start loading up Android Studio and Eclipse and all that. And I got to use their SDKs. All to do what is basically some two-dimensional text layout and graphics. This to me strikes me as just wrong that we do this. And so I pointed this out to my friend. And I said, hey, did you notice that I just happened to do the thing that I think is better than this complicated thing, where you've got a completely separate code base for the iOS app and a completely separate code base for the Android app? I made a cross-platform 2D graphics system. Isn't that cool? My friend comes back to me and says, yeah, but it's not cool until you do it 3D. I'll be really impressed when you do something 3D. Me being the sort of competitive person that I am, I was the same way in snowboarding too. When people would, I would sometimes, oh, you can't do this trick. Okay, well, I'd go and try it out. So I'm similar in this regard when it comes to programming stuff. I just like a good competition. So I said, you know what? Screw it. I'm going to try to do something 3D. And that's why I started. And it was also to battle this conception, because I hear this one a lot. I get this criticism a lot. Or this is in the air, shall we say. Custom game engine is just fine if you do 2D, man. But if you do start doing 3D, it's not going to work. It's too much to do. Now, there is a sense in which that's kind of correct. And I actually can empathize with and understand that perspective, because when it comes to prototyping the gameplay of something, if it's 3D, you're just going to have a lot more work to do to prototype that game versus if it's 2D. So I think when you are just prototyping the gameplay of a game, I think that's a totally separate thing, and it probably should be done in 2D because you're going to be able to get to your answers much more quickly. Okay? And then maybe you finish the two-dimensional prototype, and later you decide to make it 3D. But I still believe that 3D is well within one's capabilities. I still believe that you can do a custom game engine in 3D if you are willing to make some trade-offs and impose some constraints on yourself. Okay, and that's what I did. So I wanted to challenge my friend, and I wanted to show you that there are perhaps, in my humble opinion, some misconceptions out there. A lot of those misconceptions, I think, come from, the engineer that instead of focusing on the gameplay, spends like 10 years on the engine. They've got this beautiful engine, but no gameplay. Okay, well, I obviously don't do that. And I have a lot of content showing you why I don't do that. I still think 3D is well within the capabilities of somebody doing a custom game engine. I think you can do it. I think pretty much anybody who sits their butt down to work can do it. So that's where I was. I had some experience with cross-platform, two-dimensional games, rendering, that kind of thing when I started. And it took me about, let me bring it back up and take another sip. Not this. This. It took me about 2 months to get from 0 to this. What did I do? How did I get here? Where did I start? Well, if you can see these cubes here, see the red cubes? All of this actually started as just the red cube and just rotating the red cube. And I think I put in a little bit of fake lighting on the red cube just so that I could see it rotating. So the very first version of this, I think it only worked on Windows, and I think it only did the cube that was like rotating. And I think that there actually was not any kind of sense of space. So I wasn't, if you'll excuse me, I wasn't putting things in the world like I am here, where there's a clear camera looking down on the world, and there's a guy in the world and I can move him around. I wasn't doing any of that. I just had a cube. Okay. That's where I started. Where I eventually went was this grid underneath the cube. Because what I wanted to prove to myself was that I could do a world composed out of building blocks. Those building blocks just being cubes, right? So that's what I did. I started with just these cubes, and they weren't even textured. So this texture actually, see that like kind of pink texture thing? That's actually something that my nephew did later on. He didn't program, he's not that good. But we were playing, and he was like, oh, I want to draw some textures. And so then I was like, okay, Wyatt. And so we kind of played around with it. So that's from my nephew. But what I did was I wanted to show that I could lay these cubes out spatially, and I could start to build a world around it. And so I had these cubes kind of underneath here, and I started to learn the matrix transformation that is required in order to lay out a world of cubes. Okay. Then, once I had the ability to place 3D models into a world, I wanted to up my game a little bit, because I felt that something where I just have a bunch of cubes isn't really, you can prototype some gameplay with that, but I thought it would be great if I could actually load 3D models into this thing. And it would also be really nice if those 3D models could be textured, if they could have some kind of painting on them, some kind of drawing, right? Something, right? And so I set out to do that part. And that, it turns out, took up the bulk of the work. It was pretty easy for me to get to a point where I could put a cube on the screen, kind of getting harder where I could put the cubes in a world and like set the position, set the location in three-dimensional space. That was harder. The hardest thing was loading a 3D model that somebody else made and then making it look nice and making it fit into the world. So that's what I did. In order to do all of this, I used a great number of resources. And I want to show you what those resources are, because I don't want you to get the impression that I am some kind of genius, that you know, it just came to my mind and I 3D match. No, my friends, absolutely not. There are a number of different resources that I used to get me to where I'm going, or to where I am now. D7 Samurai on D7 Samurai on GitHub is one such guy. This in particular was very, very useful. Okay, this is his minimal D3D11 part 3. What is this? It's actually just a single gist on GitHub. Okay? It's just a big ass code snippet. And what it is it's how to set up, it's all of that kind of API garbage that you don't like to do, right? It's get me a window, set up some basic direct 3D11, get me a simple 3D model loaded on here, get me the basic matrix transformations that I can use to put the model onto the screen. All that's here, and it's all in one file. And more importantly, I might stress, it's not object-oriented. The great thing about that is you can actually read the code. It's actually just straightforward. You can just like look at it. You don't have to go from this object to that object all over the place to figure out what the F is going on. Okay? All right here. Very cool. This is what I used. So I took a great deal of code from D7 over here. That was useful for getting just something on the screen, right? I think many programmers struggle just to get something on the screen. That is the most important thing to do, just getting something on the screen, because once you get something on the screen, you can begin to iterate on it and improve it and explore it and test it. Okay. What else did I use? Oh, okay, this is my search. I used learnopengl.com. Okay. This is very, very blown up. It's your #1 resource for OpenGL. This is a little bit ironic because I didn't actually end up using OpenGL to do my different renderers. Hang on. As I told you, I used Direct 3D11 on Windows, and I used Metal on macOS. But nevertheless, I would consider learnopengl.com to have been good reading material. Something to give you some familiarity, some sense of what some of these things got to do. Okay. So I used D7 and his wonderful code to basically get me to a place where I had some cubes that I could put in space, and I could have a camera, and I could look down on the cubes, and I could move the camera, and maybe I could rotate the world, maybe I could move things in the world. Okay. How did I get to 3D models? Because if you're just getting into game development and you're very much used to using something like Unity or any other kind of game engine, they do all of this, well, shall we say, asset management stuff for you. Right? You just kind of put the 3D models in and there it is. So you at some point will need to write something that loads a 3D model. So what is that? If you're not used to this kind of thing, you might stop in your tracks. And for me, actually, this would have been one of my first attempts to do a kind of programming that is more akin to what a compiler engineer would do. And I am overselling that because I believe that an actual compiler engineer would do something much, much more elaborate and detailed than what I did, and you will see that. But nevertheless, the work of reading a text file, processing text, and then deciding what to do based on that text is essential to this really shitty 3D model loader that I cobbled together. So I'll show you some of that. I'm not going to be able to explain it, as I said, but it's not particularly sophisticated. What I have here is hang on. Oh, wait. Do I have the resources? Okay, what is this? This is the thing that my friend gave me. Actually, Bare Metal Baron, the guy in the chat, hi. He sent me this. He made a model for me. The model of the guy that you see in the video, that's him. So he sends me this 3D model. And it is written in, it's an OBJ file. It is plain text. So what I need to do is write a program, a C program or a C++ program that reads this text and decides to put it into memory as some kind of 3D model. It's basically what my 3D model loader does. It's, I guess, suppose you would say it's an interpreter. Basically, it takes this text and it parses through it, it reads it, and it makes some decisions about where to store some values in memory, how to interpret them, etc., which ultimately is a definition of a 3D model. So every single one of these lines in this OBJ file, a V preceding a line means, hey, this is a vertex. Okay, so I've got to write a program that can recognize this pattern of a V and then numbers following it. So if you see a V and then there's a space and then there's this floating point number and then there's another space and then there's this floating point number and then there's this floating point number, okay, I've got to write a program that can do that, okay? And it's got to be able to process all of these. And vertices are not the only thing in this lovely file of ours. We've also got, because it's 3D programming, what do we have in here as well? VT stands for I believe that stands for a texture vertex. So it's just their kind of, basically, it's what's called a U coordinate, texture coordinates, which tells the GPU what part of the texture to read at that end of the vertex. So it's gonna use these values to figure out where to sample from a texture. And that's how it actually loads the outside skin of the guy. Okay, so that's VTs. VN, vertex normal. This is used for light mapping. So generally, if you want to simulate light in a 3D model, you have not just the vertex, not just the texture coordinate, but you also have a normal pointing outside of a face that is formed by 3 vertices. And you use that normal to calculate a lighting value or an amount of illumination, okay? So if you want to have dynamic shadows, lighting, that kind of thing, or at least simulate it, you have these vertex normals. So you got to write a program that can read that and then put that into memory somewhere so that Direct3D 11 or Metal can properly interpret that data and make some decisions about how to draw your scene. It's a very high level description because I can't get into all the details. So vertex normals, and then a face. Okay, so I got to read through this file and I got to say there's all of these faces. A face is basically, again, you see these, it's 3 vertices. So that vertex, that vertex, that vertex forms a face. And that makes up the model. That makes up the 3-dimensional model, which gets loaded into memory, which gets presented on the screen. So again, my 3D model loader needs to be able to find lines that start with F, lines of text that start with F, and then it's got to be able to recognize this simple pattern of face number slash face number slash face number space face number slash. Why am I being so boring and in the details and in the weeds in describing how a thing like this works? Well, because I think people generally have a preconception about how big of a task something like loading a 3D model might be. They might think that it's actually a much more grand kind of a task than it actually is. And I do not mean to trivialize the work that I do, because if I did that, then I guess, I couldn't be proud of it. But nevertheless, we're not really talking about something on par with like a compiler. We're just talking about something that like goes through this text, figures out, oh, if there's an F at the start of this line, then the rest of the line is going to be a face for a 3D model, okay? Or if there's, say, a V at the start of this VN, VT, whatever it is, okay? At the start of the line, there is a token or a collection of tokens that will then tell you what following it, rather what it is that you're going to have to interpret after that token, okay? If it's a V, it's a vertex. If it's VT, then it's a U coordinate or a texture vertex. You get the point. So the 3D model loader just needs to notice this pattern, and then it needs to make some decisions about where to store the data. Okay. There are some other weird things that I had to do. So how did I write this thing? Okay, you might ask, how did he write this thing so that I could read this thing? Because, I told you it only took me about a month and a half, 2 months to get all this working. How did I start? What did I do? Well, to quote our friend, what's the popular lecturer, Jordan Peterson, I started where I could start. I started where I could start. I started by just saying, hey, first thing I think I may have even taken out this first line of text here. I think I just scrapped it. This line here, I think then I just wrote something that was like, okay, we know based on the structure of this file looks like this. It starts with all these lines that are like V, okay? And then in the middle, eventually it stops doing that. And it goes to like VT, okay. And then after that, it stops doing that, and it goes to VN. And after that, you get the point. Pattern recognition. It's much easier to recognize patterns when you know in advance what the pattern is going to be. There are implicit rules in this OBJ file that we know about, that we can more or less codify into our 3D model loader, so to speak. When we know those rules, we just say, the first lines are probably going to start with a V, and that's going to be the vertex data. And that's the first thing that we need to do. So after you detect that it's a vertex, let's move on. Oh, there's always a space after that V. That's a rule. Let's use that. Okay. Next, we're going to find something that looks like a floating point number representation. And it might be negative. Okay. It might be negative. We're going to have to follow that text as long as we can until we run out of text and there's another space. So let's do that. Oh, and there's another rule that's implicit in here. Did you notice that this file does not have any, there's always 6 digits here, right? There's never more than 6 digits. Let's put that in. That's a rule. Okay. My point is that when you look at a file like this, and it maybe seems mystifying and such a daunting task to load something like this or to write a loader for it, take a deep breath, stop, and just break it down. Just look at if the first thing that you can do, and this is actually what I did, by the way, all I did was, let me see if I can load one of these vertices into memory. Just a variable. It's just a vertex, 3-dimensional vertex. It's got 3 points on it. Can I get that into memory? Can I get that into memory? Well, actually, just doing one vertex is a fair amount of programming work. That might have been a day of work for me, right? Because what was I doing? Well, there's actually a lot of things. I have to notice the pattern of the all the lines that have a vertex on them. They start with a V, and then there's this space. And now after that, I've got to write something that can read through the text characters for a floating point number. Okay, what would this be called? This would be called like A to F or something like this. There's a lot of functions that do this. There's a lot of libraries that would do this. I want to emphasize that I wrote all this from scratch. I just did it. I didn't use any libraries to do this. Okay. What would that be? Well, you got to read the text characters, and then you got to turn them into the internal floating point representation for that. So you've got to actually be able to go and say, okay, if it's this minus character, then that means everything following it is negative. It's a negative number. Okay. And then I got to read up to the point, up until I find a dot. Okay. And whatever that is, that's the value before the decimal. Then I've got to be able to take these text characters and transform them into actual parts of a floating point number at the appropriate decimal places, right? So in this case, I need to make sure that my floating point representation of this number has a 0 at the tenths place, a 5 at the hundredths, a 7th at the thousandths, etc. On and on. That's what I got to do. Once you can write something that can just take the text for this and make a single floating point representation of that number, well, now you've got a function that can just do the rest of it, right? So that's what I did. But of course, it also needs to recognize this pattern of this space, and then this, and read through the entire file. This is the hardest part of the whole thing, was writing that model loader. But once I finished it, I now have it, so I can use it. So that's what I did. All of this code in here. By the way, this code is, did I mention that this is open source? So you could actually take what I've done in this video. This is the reason that I'm not going to step through it, is because actually all of this code is open source. I made it open source for your viewing pleasure so that you can at least understand what I did. Again, I want to qualify everything I'm saying by pointing out explicitly that this is a really shitty 3D model loader. It's not anything close to robust. In fact, what did I do at the end of this thing? I did some, okay, you see this little E here? This is how dumb I am, okay? You see this little E down here? All right, I didn't really know how to detect that I was at the end of the file. So you know what I did? I just put an E down there. And then in my own 3D model loader code, I was like, oh, okay, well, if you detect that the line starts with the E, we're done. That's what I did. So I did not actually use the OBJ file format. No, of course. I didn't just use it as is. When I ran into a problem, I was like, you know what? I don't want to look up how to figure out if I'm at the end of the file or any of that. I'm just going to put an E there, and that means we're done. And then I just, my point is, however, it works. And that's all that it needs to do. And as long as you communicate this with everybody that's working with it, that it's got this little E at the end, it's all good. What else did I do for this? I think I wrote a custom hash map for vertices or for faces, vertices which were previously encountered, something like that. I think I needed to do that for the different faces. I can't remember exactly, but And you can actually, like I said, you can look at this if you want to understand. But I did write a custom hash map implementation just with an array, kind of C-like, just because I wanted to try it and I wanted to learn and I wanted to understand what I was doing. And that's what I did. I didn't use any like standard library or anything like that. I just made a hash map. And it worked, and it's nice. And I suppose it's reasonably fast because it loads the model right away. Or I lose my place. I also want to mention another very important tool. At first, I want to mention how I even got introduced to this tool. So, a big reason that it was even possible for me to do this, really, I believe this from the bottom of my heart, is because I have some amazing friends who help me out. Bare Metal Baron is one of them. He's in the chat. My friend Joshua Manton, who I met in the Handmade Discord, has been enormously helpful. Ginger Bill, helpful. I have friends who helped me along the way and pointed me to things I think are good. And so I would say that if you're trying to do this, it will be very helpful for you to find some friends who, they're not always going to be able to help you, but they might be able to help you when you're really stuck. And there are a number of places where I really got stuck because there is this problem when you're trying to do 3D from scratch, okay? It is often the case. It's going to feel like going from nothing works and it's this total discombobulated mess to, oh my God, everything works and I can see it and it's beautiful. And it is as if you pick all of the right variables and then they like lock into place and now it works. If you don't have some friends to help you through that, because it will be very frustrating, you might be inclined to give up early. And one of my friends, Josh Manton, pointed me towards this other thing that I think is great. It's called RenderDoc. Maybe I can actually load that game into it. Now it's going to show you a bunch of stuff. Here's the game. Here's that game prototype. I'm going to launch it. If I hit F12, it now took a screen capture. This tool is great. It shows me everything that's going on in my render pipeline. This is a single call for a scene to be drawn, okay? And I'm drawing all these cubes and whatnot. I'm actually stepping through all of this, right? Kind of cool. Okay. I would not know about this tool at all if it were not for my friend Josh. So many, many kudos and props to him. And then this last draw indexed call is to draw the guy. But I can zoom in really in great detail. I can see all my different mesh. See, look, I can actually see this mesh of this guy. So the reason I point this out is because when you're going from that, gosh, everything is just a big jumbled mess of vertices and I don't know what's going on. Why does it look this way? To, hey, I can actually see this. It's working. There's a guy in the thing. It's very, very useful to have a tool like RenderDoc, which you can use to see what's actually in the data and look at it from a different perspective and start to form some hypotheses about what might be going on that is preventing you from getting the result that you want. On Windows, you would use RenderDoc. On macOS, I just use Xcode because the Xcode debugger, they have a really good GPU metal debugger that basically does the same thing. So highly useful. Recommended. Okay. No. So I get by with a little help from my friends. I would say I get by with a lot of help from my friends. Okay. Why did I stop doing this? Why did I not continue on with this prototype process? Well, there are a few reasons. One, I ended up getting a job, another mobile app job. I think I was between jobs, just kind of playing around with projects. So I ended up getting another mobile app job, and my schedule got taken up by that much more afterwards. But I also had this game, Mooselutions, which I have launched on Steam. Right around the time that I was working on this 3D model thing, I didn't think much of the Moose game. I didn't think that people would like it. But then I noticed while I was working on this 3D model thing that some friends were playing it, and they actually had gotten all the way through my game prototype. And it made me stop and think, okay, well, if people seem to be liking that game, then why don't I finish it? Or why don't I try and do something with that? Why don't I try and actually ship a game? So that's why I stopped. And this project actually helped me out greatly later on, because many of the concepts that I learned from doing things in 3D, I ended up incorporating into my 2D work. For example, when you learn the matrix transformations, which are necessary, so I'll stop and just say, okay. For example, in order to show this character here, this player character, standing upright in the T pose or whatever, I believe I had to rotate him. I had to use some matrix math to rotate him. And that matrix math, learning about that, became very useful for when I needed to do two-dimensional sprite rotation for Mooselutions. So that was valuable. Another thing that you have to do, or that becomes very useful, is this concept of instancing in 3D graphics. So this notion of instancing is much more important to get the same 3D model drawn in multiple places. So I had to learn about instancing. And then I ended up using instancing to great effect in my two-dimensional game engine. Everything is basically some kind of instanced draw call. And that enabled me to then do all of the sorting algorithms and many of the other effects. Instancing ended up becoming the basis of allowing me to rotate sprites and do a number of things that are very useful in the game that I've already shipped. So this is one of those rare cases where I will actually say it is valuable for you to take a little bit of time and play around with 3D, even if you're only making 2D games from scratch, because you're going to learn something. I can practically guarantee you that you will learn something which applies to your 2D games. I know I certainly did. Okay, well, where can you find this? Like I said, I have a GitHub repo. I'm just calling it 3D Game Engine Template. You can find me on GitHub. You can look at this. Again, a warning. This is not robust. This is not in any way meant to be used in any kind of production setting at all. This is me just effing around trying to get 3D stuff to work. So a lot of it's going to be very not well explained. A lot of it's not going to follow conventions. A lot of it's just, how did he just get stuff on the screen? But you can find it. You can look at it. It might be a useful resource for you. If anything, I hope it functions as some kind of inspiration, right? Because we're all about inspiration porn today. That's what we're doing. So with that, I will say thank you, and I will stop. If there are any questions, I'd be happy to answer. Here's a question. Are you planning on doing a 3D game next after Rogue Deck Builder? Very, very likely so. I may try this game concept, this puzzle game concept that I had. I don't necessarily want to go into all the details of what it's going to be, but it's something that I did want to explore. There is another possibility that if the Rogue Deck Builder prototype, so there's this other game that I'm working on right now. It's called Rogue Deck Builder. You'll see it. I've got a bunch of streams on it. If it turns out that people really like playing that game, and if I plan to go into full production on that, it's very likely that I will just make Rogue Deck Builder 3D, right? That really kind of depends, because I would want to do some kind of 3D game, partly just to like say, hey friend, who challenged me, like, you're wrong, I did it, I rest my case. But because I think a fully 3D game for a popular game concept, I think it would do better than a 2D game. So if there's a way that I could make my next game 3D, I would be more inclined to do that. But yes, some games, just due to the nature of what they are, right? If it's a puzzle game where the game mechanic is playing with 3D space in some way, some interesting way, then there is no 2D prototyping phase, right? The whole thing's got to be 3D from the very start. And so you've got to figure out how to prototype it just in 3D. Some things are just going to be that way. So that's that. Any other questions? All right. Well, it's been a lot of fun. We'll talk soon.